Good morning, everyone. Welcome to the fourth and final Seeing Math in Nature series from the Desert Laboratory on Tumamoc Hill in Tucson. I'm Roseanne Hansen, the Art and Science Program Coordinator. And so if you don't know, the Desert Laboratory on Tumamoc Hill is pretty much one of the oldest field stations in North America. It was founded in 1907 or 1906 actually, maybe even a little earlier, it was funded by the Carnegie Institution, and it has been operating as an ecological field station research site that whole time. And it is the birthplace of the sciences of plant physiology, ecology, and arid land studies. The science journal Ecology was actually born in the library at the Desert Laboratory on Tumamoc Hill. And we are surrounded by 860 acres of ecological, I'm going to mute everybody. If you can make sure you're muted. I did forget to remind everyone. Thank you. We're in an 860 acre ecological reserve, and a lot of the research obviously goes on there, as well as all over the Southwest. And the name Chamamagi Duag is Tohono O'odham, and we say Tumamoc now, but it is the Hill of the Horned Lizard, and it is an incredibly important cultural site as well. Thousands of years of habitation of many, many cultures, and just really fascinating place. So I want to welcome our teachers today for our Tessellations. I am going to spotlight our teachers now too, and let them introduce themselves and say a little bit about them. They're both mathematics professors and have done a lot of work in the Tessellations. So I will let Kathy, if you want to start, say a little bit about your background and then hand it over to Jan.
Sure. Good morning, everyone. It's really nice to be virtually back in Tucson, Arizona. Both Jan and I completed our PhD in the College of Ed there in Tucson. Myself 2014 and Jan 2016?
18.
Okay. And I now am in California. I have just successfully made it through tenure. So I'm an associate professor at Santa Clara University. And thank you. And I work with our elementary and middle school pre-service teachers in the area of mathematics. And really my main goal is to instill a love and passion in our teachers. So especially at that level, so that they can then teach in a way to their future students that displays and exhibits how wonderful math is. And it's not just about crunching numbers. So that's a little bit about me. Yes. Jan.
Yes, hello. I started teaching so long ago. I was a classroom mathematics teacher, and I loved teaching math. I loved it. And I think I started in 1970 something. So it was a while ago, but I loved teaching mathematics, but I realized there was always something new to learn. And so about 10 years ago, I guess, I decided to go back to the University of Arizona and get my PhD in elementary mathematics education, which was really wonderful because being a high school teacher, I really didn't see the elementary aspects of mathematics, but I came to realize how important they are. And that's the beginning really of all mathematics for students. And so I really came to appreciate that. And my experiences at the University of Arizona helped me do that. It was wonderful. I got to teach both college students and the elementary pre-service teachers. So it was great. Wonderful. I'm now in Georgia, by the way, and I love Georgia. We have a big storm coming here, but hopefully everything will be okay.
Yeah, well, if we lose you, we'll know why. It suddenly goes.
That's right.
Oh, okay. Well, hopefully not. And so a couple of things, folks, while the instructors are presenting, if you have questions, please put it in the chat. I will keep track of those. And if there's something really urgent, like oh, you can't hear, or something's gone wrong, be sure to, even if you have to turn on your sound, if there's something really bad, but otherwise, please put it in the chat. I'm here to monitor that. And during this part, from now on, until we come back to talk to each other, if you could turn your videos off while they're presenting, that really helps my recording be the highest quality. So for those who can't join us today, they'll get the best view possible. So, and then when we come back together and we go into the breakout rooms, please put your videos back on. That's great. So I'm going to step away here and hand it back to Kathy and Jan.
Okay, great. We are ready to go. So let me just start by sharing our screen. Okay. So the title of our presentation today is Seeing Mathematics in Nature. And we're going to be doing some tessellations with lizards. Okay, so first of all, a starting point is identifying or defining what are tessellations. And tessera, which is a Latin word, means small stone cubes historically found in mosaics. And to tessellate, from dictionary.com, the unabridged edition, means a form of small squares or blocks, as with floors or pavements, often arranged in a checkered or mosaic pattern. Jen, did you want to add anything onto the definition?
Not at this point. This is good. We're good.
All right, but mathematically speaking, tessellations are patterns made from geometric shapes that fit together. So this is a really important attribute of tessellations. There can be no resulting gaps or overlaps.
So I might add a little bit here. My own interests in both math and art have served to motivate me to use tessellations in my teaching of geometry. And I find that the students really enjoy making their own tessellations and then being creative and decorating them and coloring them. So for me, when we study mathematics, we're looking at patterns and the symmetry in patterns. And that symmetry creates a balance in any work of art. And it also brings out specific connections between math and art.
Okay. All right. So just a little introduction. I'm going to just watch a short video about tessellations. So here we go. So Jan, did you want to say anything about the video?
No, not yet.
Okay. Okay.
It's all good.
Okay. All right. So what we want to do next is, now that you've seen a little preview, is think about where you see tessellations in nature. So where have you noticed tessellating patterns in nature? And what we'd like you to do is we're going to discuss this, have you discuss this in small groups for 10 minutes and then be ready to share with the whole group. So we're just going to randomly put you into breakout groups.
And Kathy, while you're
Yes.
doing that, let me just say a couple
Sure.
words about patterns in nature are visible regularities of form that you find in the natural world. And these patterns recur in different contexts and sometimes can be modeled mathematically. Some natural patterns you might be thinking of include symmetries found in trees, spirals, then of course tessellations, cracks and stripes, and those are the 5 main ones. So yes, I wanted to point that out.
Okay, great. And if you have any questions, if you'll just send us a little message, you can do that when you're in the breakout room, like need help, and then one of us will come in. Okay, so I'm going to send you the.
I want to make sure everybody's familiar with breakout rooms.
Okay.
So this is Roseanne speaking, folks. Zoom has a feature, if you haven't used it yet. I know we have some teachers who've been using it all along, but some people haven't. It's called breakout rooms. And so you're going to end up in a space very much that looks like this, but you'll have just a few other people. We have 23 people. So how many breakout rooms?
Dried mud,
Say it again.
dried mud cracks, maybe? Is that tessellation?
Wow, I had never thought of that. That's very interesting.
The way
Yeah,
The way they make hexagons a lot of time in the dried mud.
they do. Wow. Oh, that's great. Any others?
What about flowing water?
You know, I think, let's see, flowing water.
The ripples is what
Oh,
I'm.
ripples, absolutely. Yeah, that's a really nice pattern. I think waves is one of the other patterns in nature. They call it waves, and that would be, yeah, very nice.
Yeah, we looked at that at the last one, the fluid dynamics and the wave wave formations. So
Sure.
what else did you guys talk about?
We talked about, remind me,
Cracks and
orchards.
Yeah, orchards and cracks and dried
Yeah,
mud.
cracks and mud. That was very interesting. Can you think of any animals, let's say?
Turtles, the shell of a turtle. The shell of a turtle, maybe?
Absolutely, the shell of a turtle. In fact, that was, I think, the first one I thought of. Definitely, definitely. Very
How about
nice.
leopard spots.
Mhm.
Okay, yeah.
My favorite.
Scales on a snake.
Yeah.
That's great. Let's see.
Patterns on a leaf, maybe. That's, some leaves have little
Oh,
cell patterns.
Or the leaves themselves sometimes.
Oh, true.
yeah, in Georgia, we have a lot of leaves, which is very different now from my Tucson experience. It's amazing when I look up at the trees and I think all those leaves are coming into my yard. It's amazing every year. So many leaves. But there's a really nice symmetry in leaves, and I can see where they could, they could tessellate onto each other.
I was wondering about that.
That's very nice.
So I'm going to pop into a couple other groups that haven't had and just see how they're doing. So
Okay.
oh, bye.
I live in Colorado, so I
So consider is considered like a leaf.
Yeah,
The say equal to a leaf, the thorn, I guess, that comes out of it.
cool. Cool,
Yeah.
cool, cool.
so you're muted, Roseanne.
Just dropping in to see how you guys are doing.
I think we're doing so. One question is, are these supposed to be tessellation patterns or just any pattern we see?
Well, go ahead and just somebody keep a list, and we'll come back to the main group and ask the teachers, kind of, is that a tessellation, or is that a wave pattern, or is that is that a spiral, or is it another type? Is it geometry, or is it some other physical form? In a couple other groups, they were talking about, so maybe the hexagons in the way maybe mud cracked or ice forms, or jaguar spots are tessellations. Did anyone say tortoise shell yet?
No,
Oh, but yeah.
but I'll put it on the list.
Think of the desert tortoise.
So what we came up with so far, fish scales, pomegranate, when you cut it open, different patterns, and same
Oh yeah.
grapefruit, barrel cactus, the spiral motion, agave, saguaro ribs.
Oh, the saguaro ribs. That's an interesting one. Sort of, I'm trying to picture,
Actually, the saguaro
Yeah.
skins, how they go up and down, the pleats.
the pleats. Oh, okay. Yeah, we'll ask about that one. I'm not sure if tessellation, so it's the repeating pattern over an area, I think, at least in terms of the mathematics that I've been reading about, that can be kind of predicted. And you'll see when you cut out the lizard and do this thing that it's a negative and positive relationship, and how it repeats over, and that can be described mathematically. It's very complicated, though. I was trying to. So Marilyn, do you teach school? Are you a school teacher at?
No, I'm
Oh, okay.
not. I'm in the program to become a teacher.
That's what you were saying.
So-
Okay, fabulous,
Yeah.
fabulous.
So it's kind of a crazy thing, but I think I'm gonna like it.
Good, good.
Yeah.
Great.
So
I'm gonna pop to another couple groups. I think we have, I'll check and see how much time, I'm not sure. There'll be a global announcement. Oh, 1 minute warning, we just got.
Okay.
And I'm going to leave this room and see how everybody else is doing. So I'll see you back in the main in 1 minute.
So it looks like
We got that, and people are coming back, and we'll just make sure no one's gets stuck in a room.
Yeah. No, they won't, because it's broke. They'll break down. Usually
Wow.
they can. Yeah. Well, welcome back, everyone.
So
Let me let's see.
am I still there?
Yeah, you're there, Jen.
I am? Okay,
Yeah.
good.
We've still got people in rooms, so, Oh no, I
No,
think it's
they're-
okay. They're all
yeah,
out. Okay.
Everybody's out. Yeah,
Is everybody out? Okay.
everybody's out. Okay, so our thoughts. So where do you see tessellations in nature? So if we'll just, randomly jump in there, as we call it, in classrooms, popcorn.
Honeycomb,
Honeycomb, okay. And why?
because they're repeating hexagons, but they don't overlap.
Okay,
And I said mushroom, I had mushroom gills as well, like on the underside of a mushroom.
nice. And you can all turn on your cameras while we're discussing,
That would be nice. Thank
so we
you.
can see all your beautiful faces.
We were thinking giraffe spots.
Okay,
Mhm,
I
very
put a
nice.
genus in the chat. It's the stinglet. It's a native bee in Australia that has the spiral beehive. So
Oh,
when
wow.
they make their comb, it starts flat, and then they start to build it up like a spiral staircase. So that's the genus in the chat.
Cool.
So that was a tetragonula.
Yeah.
Fantastic.
We were saying turtle shells.
okay. And your rationale?
They fit together
Mhm.
and they tend to repeat. And
So-
there's no gaps.
And no overlaps.
Right.
Right.
Yeah.
Also, the seeds in the middle of a sunflower.
We brought that too.
Yeah.
Cracks in mud because they don't overlap and they tend to kind of come into a hexagon shape.
Interesting.
Mhm.
We were saying pine cones.
Oh, yeah.
pineapples.
Pineapples, yeah.
The pattern on the pineapple, that's a good one.
We were talking about agave's growth
Oh.
and wondering about the relationship of the Fibonacci series with tessellations. Because we could see the patterning spiraling two ways of the agave stalk, as well as the foliage growth.
Yeah, is that Kathy or Jan? Is that a tessellation?
Maybe not in the strict sense of the word, but I do know that the agave and pine cones and pineapples, when you count the spirals, you'll find that it'll either be a 2, 3, 5. It'll be the Fibonacci numbers.
Yeah.
So that's a really nice pattern, though.
So you keep referring back to the rules to kind of test the tessellations. Is that right?
Yeah.
So I had come up with fish scales because it's definitely a pattern, but yet they overlap. Tell me about fish scales.
Yeah.
I guess they do overlap, having cleaned many fish in my early days. The rule was in my family, if you caught it, you cleaned it. But I think when drawn artistically, you have these shapes. In fact, we have a picture of one coming up in the slide where they do fit nicely into each other and they don't overlap and there's no gap between the scales. So artistically, you could think of them as being a tessellation, but maybe not a true tessellation on the fish itself.
Okay.
What about rattlesnake scales?
Sure.
They
That would be very, very similar to the fish scales, I would think. Yes.
Yeah, they overlap in nature, but they don't if you draw them.
Right.
And there are some snakes like boas, like rosy boas, that have hexagonal scales that just fit together. They don't overlap.
Oh, very nice.
Yeah. That's what I was gonna say. You have like the keeled scales versus the non-keeled.
Right.
So you don't overlap. Yeah.
Yeah.
That's a really good point. I wonder if you look, I'll have to look at rattlesnake pattern. So is the pattern versus the scale. So the pattern might tessellate.
I think the pattern tessellates, yeah.
Nice.
What about tree bark?
Mm-hmm.
Tree bark.
Yep.
Corn on the cob.
Oh, wow.
Yes.
Wonderful.
I thought of that too.
Well, I know I came up with some examples, but I think you've hit just about every one. Really nice.
We also were talking about the chatter marks. It looks like chatter marks in where earthquakes have ripped apart a series of terrains, and they tend to go in one direction, but then they pull sort of square or rectangular chunks of land.
Oh, wow.
And it seems like a tessellation. I don't know how complete that is, but the pattern repeats. Let's see, Keek said they are called stress and strain patterns, but like in Southern California, the transverse faults where the faults are pretty much parallel, but then where they rip, they create rectangular or square chunks of land that are pulled along.
Wow.
Oh, that's interesting.
I'm wondering if that's a tessellation.
I'm going to write that down to do some research on that.
Yeah.
Yeah. Look at stress strain patterns. And specifically the 120 angle is a real important one.
Huh. Interesting.
Does that same sort of pattern occur in like ice when it breaks up?
Oh, see, there's a lovely one. Yeah. Yep.
Are crystals considered tessellations?
Is what? Repeat that.
Crystal formations. Considered that?
Because the crystals are formed because of the atomic structure and the way the atoms hook together. And they do create three-dimensional repeating patterns. And that's what results in the crystal.
This is Dorothy. I'm a retired geologist, and
yes.
I'd just like to say that I know what you're talking about with the earthquakes, but it's not a regular repetition.
Oh.
Because it's, you know, a function of stress and strain in the rock mass, and the rock mass isn't uniform.
Right.
So it's not predictable exactly where the ruptures are going to occur or at what angle they're going to occur. And with the crystals, unless the crystals have grown into an open cavity, which sometimes happens, but not often, they're probably going to overlap to some extent with each other, because it's unusual for them to grow uninterrupted into an open space. So chances are they're going to have intergrowth with each other and not and will have overlap.
Great, thank you for that.
We've got some great comments. Evia mentioned viruses.
Ah.
Think about that. That's certainly a repeated pattern. Do they overlap? They don't overlap.
They don't overlap. And when we look at, you know, the pictures of the coronavirus, you know, on TV, as all of the information is being rolled out, that's a really good question. My mathematical sense says, it depends if you were drawing it, how that would be, because they tend to be somewhat circular in nature when they're drawing it. And so then that kind of takes it away from being a tessellation. You agree, Jan?
There are some viruses that have hexagonal heads.
Yeah. Yeah.
And so they're called bacteriophages. They're viruses that affect bacteria, but they're very hexagonal in shape.
So then they start to fit in to that definition. You know, they're on the spectrum of the evaluation of, is this a tessellation? And this is what I find fascinating about these kinds of groups. And we were having a conversation with Roseanne last week. When we pool our knowledge together in a constructivist fashion, which you all are doing, you know, with us, and I'm guessing you've done it in your other workshops as well. You know, you start weighing in on what your background and we call it, you know, your smartness is, which we all have smartness. It isn't just limited to some people. And, you know, I love it, Dorothy. I'm a geologist, so I know about this. And I'm guessing, Judy, you must have some kind of a, you know, medical background.
I used to teach microbiology.
Yeah. So, you know, we start putting together these pieces because this is what, you know, mathematicians and scientists do. We debate, right? We come up, certainly, you know, in math, there's proofs. It's like, okay, so why is something some way? And I understand, I don't know if we have them here today, that we have maybe some mathematicians in this group. Yes, no, today?
I don't see our retired mathematician, no.
Oh,
But
so
Mike, you teach math, right? Yeah.
I don't teach math, but I'm a computer scientist, and so there's a lot of mathematics and computer science. So.
Yeah, and it's so these.
I have a question.
Sure.
So are tessellations, I guess I was thinking of them in terms of being like a 2D thing, but does it also include 3D things? I mean, when crystals come up, I think it's more of a 3D pattern. So can tessellations be either 2D or 3D?
Jen, what do you think?
Well, I have no experience with 3D. I don't know if some mathematician has taken it to 3 dimensions. We'll be working with 2-dimensional, and I don't know much about 3-dimensional. If it even exists, I do not know.
So what we know, what we're talking about will be 2-dimensional, a plane versus a more complex form. So that's something interesting to look into.
Definitely.
What about
because
the
someone in the
about
chat said, what about sound? Because you know, you can represent sound with shapes. So bird song repeats and fits together in a pattern. So that's an interesting thing to think about.
It is. Wow.
There's something called tobacco mosaic virus.
Right.
And it makes, I've seen it on leaves, and it makes it look like a mosaic, which is why they call it tobacco mosaic virus. So
Another one, Deidre, do you have a medical background?
Yeah, I was a vet tech when I was younger, you know, and I know plants. So yeah, that's, then I became a librarian. So
yeah.
That made me think of another one though, lichen.
Well, I was thinking in terms of 3D, the dice that people use in Dungeons and Dragons that are made up of hexagons and pentagons and triangles, and they roll them, as you know.
But as they fit together, those would be triangles fitting together to create the pattern. I mean, if you put them all together.
Tetrahedral.
Exactly.
Yeah.
Interesting. I like this.
Very interesting. Wow. Other thoughts? Alex and Nini, did you have anything to add?
It's unmuting. There we go.
Maybe somebody already brought this up, but we thought maybe sometimes tree bug, which does sometimes overlap, but I think there may be trees where it does not overlap.
Yeah. Nice.
And I think someone else may have also brought this up, but leaves on bushes sometimes have tessellations, or at least I think they might be tessellations.
Good.
Nice. Any other thoughts before we move on? Okay.
Oh, Kiki's you're muted.
Oops.
No,
There we go.
Sorry. There are 3D tessellation patterns that one can look up that are pretty cool. FYI.
Okay, and hold that thought, Kiki, because we're going to be doing something a little bit later with an exploration. All right, so Jan's going to take over from this point, talking about some examples, which many of you have already mentioned.
Right. We see the turtle shells, and those shapes fit nicely together. They're not regular shapes, but they do tessellate. Kind of looks like a hexagon shape. Very nice. Next slide.
Ooh, good one.
And I think somebody mentioned honeycomb and the hexagonal shape for the honeycomb. So I think someone mentioned that one. Raspberries. I that was listed when I did a little research. So it's kind of a 3D tessellation, I guess. I wasn't sure about that one. What do you all think, Kathy or anybody?
Well, it fits the definition of no gaps or overlaps.
That's true. It does.
Right.
But it is three-dimensional, so that was kind of interesting. So I just included it because it was interesting. I wasn't sure about raspberries, but and then someone talked about there's your fish scales and the snake skins, pineapple, and those are just some of the ideas that I came up with. You came up with many more, so that was great. So I guess we're ready to move on. Our art today will involve you all making an Escher-like tessellation. And but first, I think we need to give credit to MC Escher because it's his artwork that inspired many of the tessellations that are done today. His name is, I probably won't say it right, but Moritz Cornelis Escher, or MC Escher, was a Dutch graphic artist who made mathematically inspired woodcuts, lithographs, and mezzotints. And despite wide popular interest, he was somewhat neglected for a very long time in the art world, even in his native Netherlands. He was 70 before a retrospective exhibition was held, so he had to wait a long time to get recognized. In his graphic art, Escher portrayed mathematical relationships among shapes and figures and space. And even though he only used simple drawing tools and the naked eye, he was able to create stunning mathematical pieces. I think we have a couple slides, right, Kathy, that show, well, yeah, he's most famous for what was called impossible drawings, such as ascending and descending and relativity. but also for his metamorphosis, such as metamorphosis 1, 2, and 3. I guess he had 3 versions of that. Air and water 1, and reptiles, such as a lizard. Okay. So this is an example of his, it seems impossible artwork. It's called Ascending and Descending. And as you look at it, yeah, I don't know what a mezzotint is. Does anybody know what a mezzotint is? I have to look that one up. Sorry, Martha. You see the steps, you see the stairs. They could either be going up or down. And I guess that's why he calls it ascending and descending. But if you notice, the blocks, the cubes, change as you go down the piece. And as he does his tessellation with those blocks, which appear 3D, but they really are 2D, you start to see shapes interlocking, the same shape interlocking with each other. And some are going one way, some seem to be going another way. And by the time you get to the bottom row, does it look like lizards to everybody? It kind of looks like lizards to me. But I just realized that the people coming down the steps also become a lizard. Mm-hmm. So there's so much in his artwork that you can just spend a lot of time looking at it. It's always so much fun. So yeah, next slide. This is a pretty famous artwork of his, and it's just called Lizards, and it's very similar to what you will be doing today. And Kathy, you want to take over the scavenger hunt?
Yep. So now it's your turn. And what we'd like you to do is just on your own. We won't put you in another breakout room, but just take, 5 to 7 minutes to search the internet to find an example that kind of stands out to you of tessellations in Escher's art. And so if you just Google Escher's art, a whole bunch of it comes up. There's so many choices to choose from. And then if you'll be ready to share your favorite one with the whole group. Okay. And if we can't do, if you as the participants can't do the share, then you'll just explain it, what you found. So just take, it is 10:46. So just take 7 minutes. We'll come back in 7 minutes and we'll give you a 1-minute warning. Escher is the name.
Great, thank you. Are you going to stop your screen share so we can come back to gallery view then?
Sure.
Okay, perfect.
All right, let's come back together. Thank you, everyone. If you want to pop your video on, if that's okay, Roseanne. Okay. Okay, no problem. You can't turn it on. All right, I won't know.
People turn on their own video than me doing it one at a time. I don't see a global way to do it. And then you're going to share.
Yeah. Okay, can everybody see this? So here's, I won't know who sent them. So if it's yours, if you'll claim it and maybe just say a couple quick words, how it inspired you.
That was mine. I'm the bird nerd.
Okay.
So, yeah,
Beautiful.
I just really like birds. So all his bird ones kind of stuck out to me.
Yeah. So you can see where there's no gaps or overlaps, right? And then he's used color.
So those could also be like flying fish.
Yeah. Very nice. Okay, and here's another one. This is very cool.
Oh, this is my one. I just like it because it shows him doing the painting itself, and you can see how he's working, spiraling inwards. And how much attention he's really engrossed in it. I love this picture of him.
Yeah.
And you can see the simple tools that he's using. And they
amazing.
mentioned that about him. He just used very simple drawing tools.
And also the
Amazing.
size of it. I mean, these are really big prints.
Wow.
Yeah. Okay. The next one.
Oh, I haven't seen that one.
Someone want to claim this one?
It's really cool.
To me, it almost looks like
Oh
horses.
yeah, sorry.
Yeah.
That's mine.
Okay.
That's ours. There's multiples on there. If you scroll down, there should be more. But tessellations.
Oh, wow.
The one we found was the 8 heads one.
Yeah. Oh, wow.
Uh-huh. Wow.
Very nice. Okay, and then
I was drawn to that because just the exercise of making it smaller and smaller and still keeping the symmetry and the images just blew me away. And then I realized, oh my gosh, it's your lizards.
yeah.
Yep.
It's just, it becomes a like an oriental pattern, an oriental design.
Yeah.
Okay.
Oh, that's mine.
Oh, it's one of my favorites. Yeah.
And so what drew you to this?
I liked how it tessellated, but it showed a story. It's day and night, and the birds are migrating, and they turn into the fields down below, and then they turn into the birds. So yeah.
And so with Escher, not unlike other mathematicians and artists and scientists, his notoriety came long after, probably he was gone. Dead.
Yeah, he wasn't popular
Yeah.
for a very long time.
It looks like we got that one twice. Okay.
I
Did
think
anyone else?
It was the hippie 60s that brought him back.
Yeah.
You're right. You're right.
Okay. Then this one, drawing by hands, I think. Is this what?
I like that just because you're part of the artwork. You're part of it, and it's coming out what he's drawing.
Yeah. Wow. And I think that's it that I got so far. Let me stop the share for a minute. Did I miss anybody in the chat? Oh, did I miss? Are there more in the chat box? Did I get everybody?
I didn't see the one that I selected.
Okay. All right, let me see. Okay, I don't see any more in there.
Marilyn, did we get yours, Marilyn?
I don't know. Maybe it didn't get on, but I can tell you about it.
Okay,
oh, here it
please.
is. Yeah.
Can you share it, Roseanne?
Yeah, let me open it. There we go. And let me share screen. Hold on just a second. Okay. And is that it, Marilyn? Can you see that now?
No.
Okay.
It's a bird one too, but oh,
This
there
one?
it is.
Okay.
There it is. The one with the one bird.
So go up, Roseanne, up, other way.
This the big one?
Yeah.
Yes.
Oh,
Okay.
wow.
Wow. Okay.
Okay, what I liked about it was that the big picture with the small pattern.
Yeah.
So it's like you can look at the one pattern, but you can also see the big picture. That's what I liked about it.
Very nice.
Very nice.
Cool.
There was one by Tammy. Do you see the link for 3 worlds? I think that was different.
You got that, Kathy, or do you want me to grab it?
I've
got it right here.
You got it right there. Okay.
And just have to pop.
I like the title of it already. 3 worlds.
See if I can open it larger.
Oh, that is a nice one.
Oops, no. No, I can't seem to open it larger. How's that?
Yeah.
Nice.
Wow.
I have to go back to Zoom. Now I've lost my Zoom.
Oh no.
There it is. Okay, there we go.
Wow. Okay, any other thoughts? Share before we move on?
Although one of the thoughts I had watching this is how wonderful he is at seeing negative shapes.
Yeah.
This is Dorothy. I just wanted to say I have to leave now, so I'll have to watch the rest of this in the recording. But thank you very much. It's been really interesting so far.
Nice to meet you, Dorothy.
Thank you.
Bye now.
Bye. Okay. Anybody else? Any other comments?
That comment about the negative space is really neat. It becomes an exercise for you to think that way, or to make your brain see it differently. Yeah. I had to look a long time to see the migrating birds on that one, and then I realized, oh my gosh, the blackbirds are migrating the other direction.
Yep. Yep.
Okay.
Did you notice the one where the fish turn into birds?
Yeah, that's a really neat one. My mom actually purchased a Oaxacan rug that has that design.
Is that right?
Uh-huh. That was years ago, probably in the 60s.
This is Angelita Valencia Bourbon, and I'm speaking to you from the unceded lands of the Ohlone people in San Francisco. But I am a native Tucsonan, born at the foot of Timumac Hill. I moved to speak to you about mathematics as only one way to communicate globally. It's a language of symbolism. I learned that when I took topology in mathematics in my walkabout in the academy. I learned about topology, and I realized that mathematics is just a language, and that indigenous people have always held agaves, magueys, honeycombs, all of the things that Escher is using your language of mathematics to describe. We have always held those to be part of our hearts, our minds, our bodies, our spirits. And I moved to just speak this because, Kathy, you mentioned the wholeness, without saying the word, of people from different disciplines like geology and such, pooling our generative intelligence. And that's something that Native people, indigenous people have done for many years, thousands of years. And I'm very pleased to be sitting in your circle this morning and to feel your generative intelligence. And so I just wanted to share those words with you. Thank you.
Oh, thank you.
Yeah, very nice.
Yeah. Yeah, but we 100%, agree with what you're saying. In terms of there's so many dimensions. And yeah, I agree. Kathy just said it so beautifully said. Angelita. Yeah. Anybody else want to comment? Yeah, and I think I'll just say one thing. It isn't the ownership of one discipline, or one type of cultural way of looking at things, right? It's much more than that.
Yes.
Yeah.
Lovely. Thank you.
You're so welcome. Thank you. All right, so we'll move along. And please feel free to add any comments as we move through. All right. So then what we're going to do is, before we launch into doing an art project, we're going to show just a short video on how to make a tessellation. Sound? Is there sound?
Hi, welcome to Mr. Otter Studio. I posted a how to make a tessellation video a few weeks ago, and today I thought I would show you some really quick tips and tricks for making tessellations. In the video I didn't talk much, and so today I thought I'd just share some tips and tricks and ideas for these tessellations. The artist I would definitely look at is MC Escher. These can be really, really fun, but they are a little bit mathematical, and so there are a few things that I want to share with you that will make them a little bit easier to make. The supplies you need for a tessellation is paper, a pencil, scissors, tape, and then another piece of paper to draw your tessellation onto. And then you can design it and color it in with whatever you want, with markers, colored pencils, watercolor. Tip number 1, use sticky notes to make each shape of your tessellation. Another tip, to keep it from moving around, just take some tape, roll it up like so, stick it on the back, and then as you're tracing it, that tape is going to keep it where you want it to be. This definitely makes it a lot easier. Also, how do you choose the right size? If I made a tessellation this size, I probably couldn't even fit 2 on this paper, right? Because the tessellation is going to come out this way, it's going to come out this way, so I'm not going to be able to fit it. So think about the size of your paper you're transferring it onto, and just take that square, whatever size, and just make sure you can fit 3 across and maybe 3 this way, or at least 2. And then you're going to be able to fit at least 4 of your shapes in your tessellation on that paper. This is a 6 by 6 inch piece of paper, and then the tessellation ends up being about 9 inches. So for smaller hands, these little tessellations are not as easy. If you're working with children, or if you are working with people with special needs, you might want to make these bigger. Number 1 for decorating, number 2 for cutting, and it's just a lot easier for their little hands to trace and get around. Tip number 2 is how to line up your different pieces. So let's say I'm doing a tessellation and I have this circular shape here, and then I have this shape right here. Cut out your shapes, and then you're trying to move this one across from itself, and then this one is going to go across vertically. So this one's moving horizontally, this one's moving vertically. So how do we make sure that this is in the right space? Because right, I could move this around on this, and it makes it a little bit hard to figure out where exactly to put it. One way to make sure that you're putting it in the same place is to choose one of these sides, and it's easiest if you choose one that's not like rounded, but if it comes into a nice angle like this, and all you do is just take your piece of paper, don't fold it, but just kind of bend it around and match it up on that side. And then you can make like a little mark where that touches. And then you know that this piece needs to end right there. And that is going to put it in the exact same spot that it was on the other side. Same thing with this top piece. Trying to figure out where it goes here, like does it move this way, does it move that way? Well, what you can do is just take this side or that side. I'm going to use this side because it looks easier to kind of get over there. Line it up, make a little pencil mark where it ends on that, and then you know that your piece needs to line up with that line. So now it's going to be in the exact same place up here that it was below. This is going to be a much better puzzle piece because these pieces will fit together much more nicely. Another tip is if it's not matching up exactly, just try to make sure that you can fit this line underneath and above. You might have to smudge it just a little bit to make sure that those work. If you are making these with younger children, you might want to make these out of cardstock, because then it's a little bit easier for them to trace and they're not going to bend and be as flimsy as just a normal piece of paper. Here are some ideas for tessellations. There's so many cool things you can do with this. One thing that I think would be awesome is if you did a group collaboration where each person had a piece of the tessellation and they designed it with whatever they could choose patterns. They could even choose like a topic or a theme that is going to go onto that shape, and then each of them can decorate their own, but then at the end everyone takes their pieces and puts it together into a huge collaboration. It would just be a really fun collaborative project. Also, for younger children, that might be a really fun way for them to understand what a tessellation is, and also the larger the pieces and how they can decorate it will be a little bit easier for their small hands. This is an example of learning how to mix watercolors using tessellations. So in each piece of the tessellation, we've just added a little bit more of a color to the original color. Also, flip it on a diagonal. You don't have to put these in a square shape. When you put them on your paper, you can hook these tessellations together however you want. And on a diagonal, I've never tried to hook these this way, but I'm sure you could as long as it matches up. Maybe you could use a rectangle instead of a square. So those are some really just quick tips, tricks, and ideas. Some different ideas you can bring into this are optical illusions, pattern, puzzles, repetition, and also talk about the artists that use this. Talk about textiles. Talk about design, graphic design. Thank you so much for joining me on Mr. Otter's Studio. I hope you have a wonderful day. We would love to see some of the tessellations that you've created. Post your images to Instagram or Facebook using hashtag Mr. Otter Art Studio or Mr. Otter Studio, and have a wonderful day.
Oops. Oops. Oops, sorry. Uh-oh.
Do we need
Yeah. Yeah, hang on a second.
Okay, well, no worries. That was really interesting.
I'll just get back in. All right, any thoughts about that?
Are we coming, are people coming back video now? Kathy,
Yeah,
are we
hang on.
done with the presentations? Okay.
Yeah,
So
hang on, I gotta get out of.
Did you got lost in Zoom?
Yeah, I'm locked into it. Hold on a sec for me.
Okay. Go ahead and turn your videos back on, and we'll be transitioning soon to the getting back into breakout rooms to work on these.
Is it still on? Oh dear.
No, you're good. We've got you with the screen shares done, so we're good to go. You've lost your connection or your window.
Yeah, I'll be right back.
Okay, so no worries. Any questions, folks, for Jan while Kathy finds her windows?
I will say that that first video, sorry, I'm getting a frog. That first video shows a tessellation that's really nice for young children to do because it's not a rotational or a glide reflection. It's just a translation. It's just the shapes just move and interlock with each other on a horizontal way. So it's a real nice, more simple way to come up with a tessellation. Also, the shapes very often take on a form like an animal, like Escher did. And as I was looking at that video, I saw a wolf when it was put one certain way, and then I saw something else the other way. But different students see different things, and then they decorate it in the way that they see it. And so putting it together, like she suggested, I think is a really great idea for collaboration.
That was a fun activity for those of you who have worked with kids or adults. But everyone have their cutouts ready. Then once Kathy comes back, we'll get everybody into groups. So I'm not sure what next she needs to do.
Yeah, the next video actually shows how to do a tessellation in a rotational style.
Yeah, and that's the activity we're doing. The rule for the lizard activity that you'll be doing is the rotational rule. So it's important to see that.
The form is a hexagon rather than a triangle or a square or a rectangle. So hopefully she'll get it back.
Yeah. And in the meantime, so while we're waiting for get your cutouts going. Did she back? Nope.
Well, there's someone else saw the wolf. Who was that? Martha saw the wolf.
I didn't see that. So we'll share these links. I'll get the video links from Kathy for you, and those will be on the page. So I'll be sharing the recording as I have with all the previous ones on a private page, and I'll have all the links and the downloads and everything that you need. So you can go back and rewatch these. Okay. Boy, I wonder what happened to Kathy. So you don't have a copy of that video, Jan?
I don't.
Okay.
I don't think I do.
It's all right.
Oh, I feel bad for Kathy. It's such a horrible feeling when you have technical difficulties. We may, if she doesn't come back on, let's see. Okay, if Mike is asking, go ahead and ask verbally, Mike. Just it's easier to just unmute and ask your question.
Okay, I cut out the full shape of the lizards, which contains the shaded parts, because make sure not to cut out to leave the shaded areas in. But then it says we're supposed to start cutting out the shaded areas, and I wasn't clear whether we cut them out entirely or leave them connected along one of the
It's probably
boundaries.
best to do them one at a time. And if you start with, I started with the -1. Do you see that? It looks like a 7, but it's really a 1.
Yeah, yeah, I see it.
If you cut out that shaded region.
And cut it out entirely.
Yes.
Cut it out entirely. And then that shape gets rotated in a clockwise fashion to sit on top of where you see the lizard's eyes.
So the long side, the side that is when I cut out the entire thing, the side that is not connected to the lizard in any other place, that edge touches just lays on top of the left side of the lizard's head there.
It does, and it's already there, which might be confusing, but I left it there purposefully so that you would see how that -1 piece will fit right on top of the piece that's already there.
Thank you. I'll try it.
Yeah, it just goes. I had the same question, Mike. I was trying to fit it to the side, but it actually you're putting it on top to show how these how the shapes repeat and come up again within the actual lizard. So you can, when she says you can see the shape, so look at just above the eyeballs, you can actually see the horizontal line, and that's literally just put it right on top of that. It'll make sense once you stick it on top.
And the way that you cut out
The
pieces
edges,
and
so
then
when I rotate
rearrange
it,
them.
when I rotate it and put it on top of the nose, it doesn't fit flush against the lizard. It sticks out.
No. Let's see, how can
He's having the same problem I did. So here,
Maybe
we'll hold it up.
If you could just
So
show a
Mike,
picture of the first one going.
there we go, Mike. Look at the, can you see my?
So from here to here.
Oh yeah, that's good. The shape where you'll be placing that -1 region is already there. You're placing what you cut out on top of it.
Not next to it.
Not next to it.
Yeah.
What about the 1?
Totally get it now. I just needed that.
Oh,
picture.
you see?
Oh, I see. Yeah.
Yeah, I was trying to put mine to the side. And it was just wasn't
It's not on the outside of the lizard. It goes inside the shape of the lizard.
Yes. And you can see the drawing of it is already there as a little hint.
Yes, got it.
And that's kind of, isn't that, Jan, isn't that the visual representation of the mathematical, the geometry, because it's showing how it's repeating and how you're taking the negative space and where that exists in the positive space.
In order to have a tessellation that rotates, you have to cut out and rotate the pieces first. In
Right,
that
but if it
first
just fits
video,
on top, if it
they
just
were
fits
not
on top of
rotated
the
so that
existing lizard. Oh, I'm sorry.
the pattern was just horizontal. But if you want a rotational tessellation, as pieces are cut out, you have to rotate the pieces, which goes to the genius of Escher to be able to see that and to come up with a shape that's recognizable. I think it's just amazing.
Yeah, what was confusing to me was that if you just cut them out and didn't tape them on top of the lizard, you would still have a tessellation. Because
I mean,
the lizard shape was
those
constructed
pieces are
to-
not really there, but I left them there so that you could see how it was done.
Sure, got it. Now I get it. Thank you.
Thank you. Yeah. I wonder, Jan, if we should move to the activity. What do you think? I'm not.
We certainly can, sure.
Kathy's Kathy's not, she hasn't, I'm looking, waiting for a phone call. I have no communications from her. So,
Cool.
So I think we can always Is everyone comfortable starting the activity without looking at the video? Alex, yeah?
Good.
Yeah. Okay, then I'm going to do the breakout rooms. Jan, anything else you want to say? What would you like? Maybe tell them what you would like them to do. Follow, you've got your instructions. And then Jan will walk you through it. And how long we're going to take? Are we going to take like 30 minutes?
Sure. I know when Kathy was talking to me about it, she thought that she needed to make 2 lizards and to show how they fit together, but you really only have to make 1 template. And then if you have another sheet of paper, you can trace around that template like they did in the video.
All right.
Yeah,
And
so
then-
you can do it either way. You can cut
Sure.
out all 4 and play with them.
Right.
To make a pattern, or feel free to cut out just 1. And there she is, Kathy. Yay!
Oh, yay.
Let me make you co-host again. Okay, we were just actually going to start dropping into the breakout rooms. Everybody's pretty ready to go, but if you want to play your video, that's great too.
Oh, let's play the video. I'm confused.
You don't want to do it? Oh wait, you're
Yeah.
muted. There we go.
Yeah. The other one doesn't add a whole lot. It just shows rotation. So I apologize, everyone. My computer just completely froze.
That's okay. I
Yeah.
think everyone's pretty much comfortable starting.
Yeah.
And so if you want to do the breakout rooms, or they're
Sure.
ready to go. We had some
Okay.
people had to leave, so
Okay.
we have fewer people.
All right. How about we put
Will we have a chance to see the rotation?
the video?
Uh-huh.
Sure. Do you want to see it?
Yes.
Okay. All right. And then if it bombs out my computer again, I'll
And
see you in
we'll
the
be ready to
breakout
go.
rooms.
Okay.
This one has no sound.
And Kathy, this is showing the rotational rule. Is that correct?
Mm-hmm. Mm-hmm.
Okay, thank you.
Like I said, it's a silent.
Our lizard though is already created as a rotational design. We're not actually removing pieces and taping the pieces on the outside.
No, we're just taping the pieces back on the piece of the lizard itself. And
Yeah.
I'll show you my sample.
And that's because this rotation's already done.
Correct.
But if you finish, you could try making your own, you know, come up with your own design, and that's always fun.
Yeah, if anyone's feeling brave, do your lizard and then try creating your own rotational design.
Sure. I think that's where students have the most fun, because they love to come up with something and they see something in it, and it's just amazing what they can come up with. So you can see how he rotates the piece as he makes it fit into the other pieces. He spins it around.
So is the spin always 90 degrees if you started with a square?
I think so. Yes, I believe so.
As you can see, he just continues until he has the whole paper full.
Yeah. Very good.
It's faster and faster. And then once you cut out your lizard, you'll be able to do the same thing.
I have a question.
Sure.
So first he goes one way and then the opposite. Is that what I'm seeing?
Right.
You mean as far as tracing?
Yes.
Yeah, I think that that's what he's doing, but he's seeing where the pieces will fit like puzzle pieces. So, and you'll see that too as you do the lizard tessellation. You'll see there's only one way to make it fit, so there's no gaps or overlap.
In science.
Okay.
All right. Good. So is everybody ready to start? Yeah. Okay. So I've cut one out, and then this will be my stencil, and then you can rotate and create your pattern with as many of these as you'd like.
There's a couple more slides, are there not, Kathy?
Yes. Hang on. I didn't know how far you got. Okay, here we go. Jen, go ahead.
Right, and I think everybody already knows this, but we're going to use this lizard pattern. You can go to the next slide. And I think in that very first video, they said that you would either use rectangles, triangles, or hexagons. We are using the hexagon today, and we're using the rule of rotation. And it's important to remember that anytime you do a tessellation template, whatever you take off of the shape you start with, it's got to go back somewhere. So otherwise it will not tessellate. And so everyone has that shape. I think we answered everyone's questions, but if someone still has a question, just let us know. And if not, I think we're ready to go. Kathy, the next slide shows what they already have, I think, on paper.
Yes, that is, they already have these instructions, yes.
Okay.
All right.
But if there are any questions, just, feel free to ask.
Otherwise, we'll go ahead and put you in the breakout room so that as you're working on it, if you have questions, you can ask your participants in your room, or just in the breakout room, there's a place for you to ask questions, contact hosts, and one of us will come in. Okay?
All right. Location of where I slotted them together, then it did make a tessellation.
So Muffin, you had a question?
Oh yeah, we were in looking at the original hexagon from which the lizard was created. It doesn't look like a symmetrical hexagon. It looks like a lopsided hexagon. And we were wondering if any old hexagon would work, or whether it has to be close to symmetrical.
Oh, that's a good question. Let me go. Yeah, I see what you're saying. Keep playing with these though. I know these will work simply because you're making it from this. I think as long as you're making it from the same shape, it should work. It just like, think about a tortoise shell. They're not perfect, but because it's related, it works as a tessellation. Does that make sense?
Cool. Yes, that's helpful.
And the reason they had you cut out the shaded piece and find that piece on the lizard is to demonstrate how the tessellation was created. It was wasn't quite intuitive, but once you see that, then you can start playing. So did that answer your question then?
Yeah, beautiful.
Okay, great. Hi, how are you guys doing? Good?
I got the 3 in the center.
Nice.
Three heads here. 1, 2, 3. Fit together pretty well.
Oh, how fun.
But when I go to add ones out from it, they don't fit quite right. Whoever designed it, it's just not.
Okay, we'll talk. We'll ask Jan about that. Okay, so five more minutes. Okay.
Sure.
Okay, I'm gonna go to the next room then.
Sure.
Okay, so 5 minutes. We'll do a global warning. So look at your chat.
Counts.
Yeah, I was wondering that too, like snowflake, like a snowflake. But...
About three more minutes. Okay, 2 more minutes.
Okay, sounds
Yeah,
good.
do you know, so when you're rotating, do you erase? Like, should I be erasing lines?
No, they should, if you've got, so what are you calling rotating?
Well, I don't know if I'm doing it right then.
So you're looking, so you're
okay.
Looking for, when you're looking for where they fit.
Yeah, I did that.
Okay.
But then like where it overlaps.
So it shouldn't be overlapping.
It's not going, okay. My dyslexic brain isn't liking this.
I know, it's actually, it's not easy. Don't worry. So it took me.
I guess because I thought we were matching like the -5 to the 5.
No, don't, just ignore that now.
Okay.
So just go with the cutout shapes.
All right. So so I have like one in the middle of the page. And so I need to find where the head fits next.
Yeah, exactly.
Right. See, and so where I'm putting it.
See, here's a little hint right here.
Like it's overlapping. Hang on. Okay, so I did that. I thought, hang on. But wait a second. Oh, because I don't have the cutout. That's why I didn't.
That's right. So you just good. You demonstrated.
Well, I erased the line because I had to erase the line because I didn't cut out the other shaded area.
Okay.
So I should cut out all the shaded things.
Okay.
Is that right?
I'm gonna pop over to another room now. So let's see. It won't let me. Okay, room 3. Here we go. Wait, am I in room 3? Where am I?
I don't.
Yeah.
How you guys doing? We're almost ready to finish up.
We're getting stuck, so we can do the 3.
Okay.
But then as soon as we try to like branch out, then
it doesn't work.
It doesn't work.
It doesn't work.
Okay.
So, and we've been drawing it too and tracing it, and it's just like we get to a point where then we're stuck.
Yeah, I haven't made it beyond 3 because I've been going from room to room. So I think when we come back to the main, then we can ask these questions. In fact, why don't we just go ahead and.
This is as much as we were able to get beyond 3.
And this is pretty 3-dimensional, basically. Who knows if it
Doesn't
would
want to
actually
lay
work
flat.
2-dimensionally.
Tell you what,
Might be-
let's everybody go back. Let's go back to the main room so we can ask questions of and look at Kathy's got her, or Jan's got her example of her finished ones.
Okay, thank you.
Come back to the main.
There we go. I only got to 3.
Okay.
I couldn't get beyond 3.
Okay, can you lift your paper higher?
Little bit close. Oh, there we go.
Yeah.
Yes, he said this is the 3rd person who said they couldn't get beyond 3.
Huh. It kind of morphs out if you get any if you keep going with the drawing like that.
I just found the how to get beyond the 3. It took me a few minutes.
It's like you need to make a bigger lizard. And then it would work, but.
Was that you, Linda, that was just commenting?
Yeah.
Okay, could you say that again?
If you go beyond the 3, it's like the next lizard has to be bigger than the lizard than what you started out as. A little bit different configuration because the piece.
I can see where the tail is supposed to fit on the top of your.
Yeah, you can see where the tail goes.
Uh-huh.
And you can see where the heads go. Let me see if I can.
But if you put that tail in there, then you
tail in there and see what happens to the legs. The legs go off in a different direction.
But that's the arm. That space that I see there is where the arm's going to go. I think.
See how it doesn't actually configure.
Kathy, maybe you can show the picture of the one that I did.
Sure.
That might be helpful. I don't know.
I don't know if it's just because okay.
Can everybody see that? And actually I can put this, it's a file. Oh no, it's not mine. It's Roseanne's. Sometimes you can share a file in the chat box. Can I do that, Roseanne?
Yes, you can, but not everybody will be able to access. If they're on an iPad, it's a little bit more difficult. But go ahead and try to drop that in.
So that's what Alex and Nani started doing, is making it into like a horizontal thing instead of a true rotation. And that seemed to work better. So that's what you did here. But she started with the tails, not the.
Sure. I mean, you can see where the head's going to go, and you can.
Okay, so you can't really start with the 3 heads together.
Right. If you start with the 3 heads together, you get
that's all the farther you get. Right.
Yes.
So you have to start with the tails together.
It shouldn't be. You should be able to, and that's something you can maybe keep working on. But you can fill the whole page with this list.
So, but the way you do it, like you can't do like a 90-degree rotation every time because.
No, you can't, because you didn't rotate the pieces 90 degrees every time.
Okay.
So it's just a matter of fitting it in so that there are no gaps and there are no overlaps.
I'm putting him in the chat box now.
So yeah, I think if we could go back to why the 3 is so difficult, because I agree with Judy. Once you get the 3, then finding this where to put the next one is not working. So we'd like to understand kind of why that is.
Huh.
Because it definitely works if you go across, but not if you start with the heads together.
Yeah. Well, it may not work that way. It may be that you just need to fit the pieces where they fit.
Someone in our
It
group,
sounds kind of silly, but
so then is it a true tessellation if it won't repeat then?
Yeah,
For
it's
me, that was true.
The pieces are you do rotate different amounts, I guess, for each time, because the pieces that you used to make the lizard, they were rotated like 90 degrees and 120 degrees. I mean, all different.
Okay, but the drawing that you showed had 3 heads together, and then the next segment had 3 tails together.
Okay.
That were done horizontally.
That's okay.
Okay.
That's okay.
So you can't always assume that you're going to have heads together when you're doing it.
Right. It'll show up again somewhere.
It'll repeat.
It will repeat.
Mike, were you trying to say something?
yeah, someone in my group pointed out that the underlying hexagon was not totally symmetric. It was a little bit off.
It's not a regular hexagon. No, it is not.
At least,
and that just affects the final shape of the lizard. So whoever came up with this, and it wasn't me, had a real good eye for how to make a lizard look like a lizard from a hexagon.
well,
go ahead, Mike.
What I'm finding when I try to put them together is it generally fits as a tessellation, but I'm seeing small gaps, and I think it's due to the fact that it seems to me that that's probably due to the fact that the underlying hexagon was not symmetric.
Oh.
Yeah.
Interesting.
Could be, yeah.
Can you share is everyone able to open the file that was put in the chat? Otherwise, we can share the screen again to show one of the ways multiple versions of the lizard fit together here. But this was hand drawn, so I think it smoothed out those gaps you're talking about, Mike. Is everyone able to open that?
Yeah, I agree. I think that, yeah, I mean, the gaps are really small, but they're noticeable. It doesn't totally tile, the physical pieces don't totally tile on my table.
So if you start with the 3 heads together, then like a lot of us did, it is going to stop at 3. So you want to pull them apart and try a different way so you can go infinite, right? That there's only going to be certain ways that are infinite, not.
Mine worked with it starting with 3 heads together.
Oh, can you show it?
I can try.
Just hold it up, maybe.
Well,
I
it's fall apart, but if I can, hang on. Oh, never mind.
Or maybe take a picture of it and then put a picture in the chat box. Oh, there we go.
You start my video.
Oh,
where did he put it?
He's got one. Yeah.
Very nice.
Were you
Oh,
two in the
cool.
same group?
These gaps here, like here.
Yeah, a couple of little.
Huh.
Yeah.
I mean, there's only, yeah, I mean, it seems like there's certain places, like the tail has to fit into between the left two legs. Every
Didn't
time.
have
I mean, there's
that,
no other
that
place. for it
issue.
to go.
That's interesting.
Oh, sorry, Mark didn't finish talking.
I'm sorry, Mike.
Oh, I was saying, I mean, the tail only fits into one place, right? I mean, it only fits in between the left two legs, the two left legs. So, I mean, it kind of dictates where you put it together, but at first I didn't think it was fitting together because I was getting those gaps, but then I realized it was just because there just are these gaps in it.
It would be really great if everybody, when you get a pretty far down, putting your pieces together, take a photo and email it to me, and we can share it on the website for everybody to see what we've all come up with. Because I think it's going to take a lot more time for you to move these around and get a feel for the repetition and the patterns and how this is working. And then you can play with, if you want to trace them and do some, add some detail, make them Gila monsters or something.
It looked like on Judy's, she had the lineation, like that line down the center of the lizard, and that emphasizes the way the patterning and the rotation is going. It was helpful to see that.
Really cool.
Wow.
Yeah, Judy, you've already started coloring him.
Well, I just colored them in so I could see how the tessellation was working. Like here's a red one and here's a red one. Here's a green one and here's a green one. Here's purple and here's purple. So I could see how it tessellates. It just these extra spaces. Like Mike said, the underlying hexagon is a little skewed, I think. It should work any which way, I would think, but I'm not an expert on tessellations, but I would think it wouldn't matter if you started with the heads or the tails.
Yeah.
But I'm going to try drawing it next and see if that works out better than trying to piece together the ones like a quilt.
So
I would think too, if your cuts aren't like super exact.
Yeah.
Too, like I cut mine kind of quick. Well, I cut some of mine like kind of quick. So I have like a little bit of extra like on one black line, and then one I cut into the black line because I'm not very good at cutting. I have horrible hands. So, but yeah, I think that would throw it off too a little bit.
Mm-hmm.
So was the decision that the symmetry of the hexagon does not matter?
That's a question for Kathy or Jan.
Yeah.
Yeah. Jan?
Well, I guess it's hard for me to answer that because I didn't get the same issues that you are having. So I'm going to do it again and see if I can figure out what's going on here. I think that because it's not a regular hexagon, the shape of the lizard is affected, but I still think you should be able to tessellate. I don't know. I'm going to find out.
Well, I didn't realize I was supposed to cut the 4 out and piece the pieces together. I drew it instead. And I found some of the same things. I thought maybe it was because I'm not a precise person. But so I just drew one and then tried to fit in, where it would fit. But eventually the lines couldn't match up anymore. So I don't know if that's because I'm imprecise, or as Mike said, if there's an issue with the hexagon to begin with, but it didn't work for me for drawing either.
I would think if the hexagon is not symmetric, then you would not get a tiling of the plane. And if you don't have a tiling of the plane with the original hexagon, cutting out the pieces and rotating them is not going to fix that.
Yeah, so you see, like here, all of a sudden, I've lost a space for the tail. I mean, it just, each iteration seemed to be more off.
Right, right. I agree.
This is Deborah. My video has been blocked for quite some
Oh,
time.
Let me
But
see. Let's see. I'm working on that, Deborah. Let me see what's happened. I
well,
might
what I
have.
was gonna say is that my printer was broken or is broken. And so I just did my own design. And some of the issues that people have been talking about with the lizards is what I found with my own design. As I went on, it wasn't, oh, there, okay. This was a design that I came up with.
Ooh,
I don't know if you can
nice.
see it.
Yeah.
And then when I did my drawing, I did it in pencil. I don't even know if you can see it.
Yeah, we can.
It went pretty well. And then all of a sudden it was off by, in this one corner down here, it was off by a good 1/4 of an inch. And every place else it fit except there. And so I don't know if there's something about, maybe I wasn't precise enough with some of my drawings, but I don't know. It just, it seemed like as I progressed, it fit less perfectly. So
I think,
anyhow.
what rule did you use to do your shape would be a good question to start, and then maybe Kathy or Jan can address that.
Yeah, I used I guess it's the rotation. I don't know.
Okay.
It was a square to begin. But anyhow, I wasn't meaning that my problem had to be solved. I just was saying that doing my own, I had some of the same issues that you're talking about.
Right, the precision of the pattern.
Yes.
Matters.
Yes.
Yeah.
Yeah.
Which gets back to, artists. That's where the art and the math come together. The art has to be so precise, right?
Yeah.
For the mathematical shape.
Yeah.
Well, we have come to the top of the hour, and I know some, this is I know some people have things they need to do. They set aside the 2 hours. So Kathy and Jan, do you want to do a quick wrap up? And
Sure. All right. So just some things to think about. Is some reflection questions. How does our work today add to what you know about tessellations in nature? And what do you want to further investigate? And then just be thinking about some of the questions you have about tessellations in nature. And I think Jan and I would be more than willing, especially if there's a place, Roseanne, where this wonderful group can pose questions, and then we can do some fact finding and answer them.
We don't have a chat on the website. That's an advanced thing that the U of A doesn't allow individual chat areas. But you can certainly email questions and we'll get them to Kathy and Jan.
Yeah, and we'll get back to you. And we just want to say, we hope you've enjoyed your time with us and our presentations on tessellations. And we thank you very much.
Thank you.
Thank you very much. It was interesting and fun.
Thank you.